Hello, it's me, it's John Park. It's time for John Park's workshop here at Adafruit. Thanks everyone for stopping by here today. It's been a little while. Sorry, I was out earlier this week, and somehow my blog post I managed to imagine rather than actually send, letting you know that I wasn't going to be doing the Tuesday show. So huge apologies for anyone who stopped by and wondered where the heck I was. This thin man over in our chat says, hope you're doing well in this crazy heat wave. Yeah, actually not as bad here in Southern California. I had to head up north near Sacramento, and it was like 117 degrees Fahrenheit the other day. Woo! So it's actually not anywhere near as bad here in the LA area. So thank you though. Yeah, and look, here's our chat. If you're wondering where are all these good chatting people chatting from, head on over to our Discord. It's at adafru.it/discord. And you can hop into that live broadcast chat channel that you see right there. And here we've got Franklin, Thin Man, Johnny Bergdahl, Gary Z, Andy Calloway, Tyeth, Liz, Split City DIY, hello, C. Grover, Paul Cutler, and anyone else who I forgot to mention. Thanks for stopping by. We've also got people over in our YouTube chat. Hello to Dave Odessa and Johnny Bergdahl over there. And come on by if you're somewhere else and there's no chat. This is probably the place to be. Hey, Steve. Okay, you're on. Chatty chat. Nice to see you. Thanks for popping in. So, what's happening here today? So, as I mentioned, I wasn't here on Tuesday, so I do not have a product pick recap, but I will be back on next Tuesday with a new product pick of the week. I've got a coupon code for you in case you want to buy some stuff at the Adafruit shop and save a little bit of money. You can save 10% off. I'll give you that in a minute. I do have a CircuitPython Parsec. This is a kind of a neat one that was suggested by Todd Bott, our friend Todd Kurt, and it's a practical one, so hopefully it'll be useful to some of you. Not that they're not all practical, but this one is very bread and butter, and I think you'll dig it. Let's see what else. I've got a project that I'm sort of kicking off. I worked on it a little bit. I don't think I've mentioned it here before, but it's in good shape. It's going to become a Learn Guide pretty soon, so I'll call it a kickoff. I can't remember if we've discussed it before, but I'll show you that. That's a pretty neat thing. Could be useful. And that's going to do it. That'll be today's show. So, as I mentioned, first of all, I've got this right here, which is your coupon code for today, and it is related to both the grilling you might be doing in this summer weather. It's also related to the project that I'll be working on, and it's propane. If you're not familiar with that, if maybe you call it somewhere else where you're from, that is the tank of gas that we use to heat up a lot of our grills and things, particularly here in the States. You can go and get a white tank of gas, refill it. Liquid propane heats up your food. So propane, that's the grilling-based hint today. Your coupon code, and what you can do with that, head on over to the Adafruit shop. That's it right there. Head up to products, maybe what's new, or new products view all. Check out some of this neat stuff. We've got just launched in the store. We've got a vertical breakout for USB-C. That's a pretty neat one. I might pick up some of those to play around with. A new high precision temperature and humidity sensor. We have IR remote transceiver. We've got a RS-232 PAL, which is 2-channel UART to RS-232 level shifters if you're doing some talking amongst maybe older machines. And more. So pretty much anything you see in the shop that is a physical thing. You can't use this on the software or gift certificates or subscriptions to things, but if you're looking to buy some physical stuff and you want to get 10% off, that's the coupon code, propane. You'll just head to the coupon code slot in the checkout page on your way out. Just type that in, hit go, boom, it'll take 10% off of your order. And since I'm talking about the store, I'll also mention if you want to know what kind of free stuff you can get by buying more, then go to adafruit.com/free. And that'll show you the current freebie deals that we have going on. So there's 4 of them. If you order $99 or more, you can get a free PCB coaster, that nice Adafruit coaster right there. $149 or more, you'll get the coaster as well as a KB2040 board. If you order $199 or more, you'll get the coaster, the KB2040, as well as free UPS ground shipping. Free UPS ground shipping in the continental US. And then if you order $299 or more, you'll get all 3 of those perks plus a free Circuit Playground Express. And you can also use the 10% coupon code on your order. I don't know if that applies, the freebies apply before or after that. So if you have a question about it, you can check with support@adafruit.com. Double check, the address is listed right there, in fact. Double check on that because I'm not sure how that works. All right, yeah, so that's the coupon code and new stuff and free stuff. I'm going to stay hydrated since it is a bit hot out. And like I said, no product pick recap, so we will jump straight into this CircuitPython Parsec. Here we go. CircuitPython Parsec. All right, here we go. So what's all this, you may ask? For the CircuitPython Parsec today, I wanted to show you how you can get into the bootloader for a bunch of different feather boards. And this will apply pretty much to our other boards as well. They're usually pretty similar. And they follow along chip lines usually. So what this means is when you have a board and you want to put a new version of CircuitPython on it, there is some sort of a reset magic finger button combo that you can do that will get you the feather boot drive or some version, some variant on that name. And so I want to go over those. So first up we have here the Feather M0 Express and the Feather M4 Express. These work pretty much the same way. And what I'll do is, let me bring up the little cheat sheet here per board. What you'll see there, I have my Finder. I'm on a Mac. I have the Finder, and it's showing me what drives are connected up right now. So in this case, I'm going to plug in this Feather M0 Express. After a moment, you'll see a CircuitPy drive shows up. So it's running whatever CircuitPython code is on there. If I want to get either the M4 or the M0, they act the same, into the bootloader, all I'm going to do is quickly double-click the reset button. So each of these is going to have a reset button on the board. Tap, tap, double-click, and after a moment here you'll see a drive named Feather Boot shows up. And that's actually the same, both the M0 and the M4. Plug that one in, double-click, and there we see Feather Boot. Next up we have an NRF52840, and that's the same for the NRF52840 as well as the NRF52840 Sense. So I'll plug that in, and these as well are a fast double click on the reset button. You will see, however, you'll get a different drive name for this. This is Feather 840 boot. So that's when you've got the NRF52840 in there. And again, you can now drag on a UF2 file, such as a new version of CircuitPython. Next up, and let me just, for completeness sake, add that one right there. So there's NRF52840. Double-click the reset button. Next up, I've got an RP2040. So this has the Raspberry Pi RP2040 chip on it. I'll go ahead and plug that one into USB, plugged into my computer. And this one you'll see is a little bit more elaborate. We're going to hold down, press and hold the boot select button. In this case, it's on the end. Sometimes there will be a boot select button on the face of the board. But on this newer revision, it's on the end. So I'm going to press and hold boot cell. And then while I'm pressing and holding that, I'll press and release the reset button and then release boot cell. And you'll see the Feather's boot drive shows up. But in this case, it's named RPI-RP2. That is the Raspberry Pi RP2040 boot drive name. It doesn't say Feather boot on that one. So once again, that is, if we just press reset, we'll get back to whatever drive it was. If it's running CircuitPython, you'll see a CircuitPy drive. In this case, I don't think this one is. But if I want to load CircuitPython on, I'm just going to press and hold boot cell, press and release, reset, release boot cell, and there you go. You've got the Feather boot drive there. And then the last one here is ESP32S2 and ESP32S3. Both act the same way. You'll see in this case we have, deceptively, there is a boot button on here as well as a reset button. We don't use the boot button in this case, and I always forget this, and I just go for it. And after a while, I scratch my head and look it up. So no need. Here's the cheat sheet for you. On ESP32S3, ESP32S2, it's the same. You're going to do a slow double-click reset. So not to tap as fast as you can, but it's got a little bit of like a pause between them. You'll know it's time to press it the second time when you see the indicator go purple. So 1, 2. So tap, tap, like that. So a moderate speed. I call it slow. It's not your fast as you possibly can, which is usually what you do on the M0 and the M2. And so there you can see we get a boot drive in this case that's called Feather S2 boot. If it were the ESP32S3, you'd get Feather S3 boot. And so these are all of the sort of most common boards you're going to show up, most common chipsets that you're going to see. There are variants on them, the CAN bus versions of some of these and the TFT versions of these, but they'll all act pretty much the same for a given chipset. And so let me pull this out of the way here. That is how you can boot into the boot drive on a bunch of different Feather boards, and that is your CircuitPython Parsec. Over in the chat, Paul Cutler says, Toddbot recommending to JP to talk about bootloaders. That's on point. Yes, it is. I don't know where that came to Todd, that he suddenly was like, hey, wait, do this. It's helpful. You end up forgetting these. And maybe just make your own little cheat sheet, or you'll have this video. I'll make a little 1-minute version. You'll have that to reference. But those are available. That info is available on the Learn Guide page for pretty much all of these. In fact, I'll show you just as a little add-on here. If I go into, even starting at the store, let's say, if I do Feather ESP32S3, and I'll click on one of these product pages, I can then scroll down and I'll find that primary Learn Guide for that board. And if you, generally speaking on these, since these are all CircuitPython boards and the CircuitPython instructions will tell you how to get CircuitPython onto the board, just click on the first CircuitPython link you see in the Learn Guide. And as you scroll down, you will see here's a helpful graphic and bit of text. So in this case, it's showing the reset button there that you're going to slow double click, as is highlighted in red, and then the little tiny NeoPixel, I think it's a NeoPixel, could be a dot star, little tiny RGB LED there is circled in green, or has a highlight in green in a square there. That is the LED you're going to look for to turn purple, meaning you've successfully hit that first reset, and then you're going to hit that second one. But yeah, if you just give it a little like pause, like an eighth note pause, that's enough, and you'll get a successful bootload on those. So you can go through, you can find these for all of those, but let me know if I've missed any. I think those are pretty much all of our chipsets that do CircuitPython, is the M0s, the M4s, NR52840, ESP32, S2 and S3, and RP2040. I may have missed one, but those were the ones that when I looked into it, I was like, yeah, that's kind of pretty much those are the boards. There are others that you can get it on there with more antics. Like I think you can force it onto the ESP32 that does not have a bootloader on it, but it didn't really fit into this format. So there you go. Thanks Todd for that suggestion. If you have suggestions of things to show or questions on how to do some stuff in CircuitPython that you'd like me to cover in that segment, then please do let me know. All right, as Space Pope over in YouTube said, yes, so important to stay hydrated, so I will do that again. Some nice over in our chat said that the Pico, which I think you might be referring to the ESP32 Pico V2, I think that's the name of that one, which is hold and plug. Okay, so that's a hold the reset button, plug it in, and release. Is that the one you're speaking of? I think it may be, or maybe you're talking about the actual Pico. One of those, RP24. Yeah, that one has no reset button on it, right? The official one has no reset button on it. Yeah, RP2040 Pico. Yeah, that one. So I covered feathers here. Most of those instructions I think are the same on Itsy Bitsies or Circuit Playground Expresses or Cutie Pies. Yeah, okay, yeah, everyone's confirming plug while holding boot is the RP2040 method. Thank you. All right. So, yeah, so many things are called Pico. Eventually, everything evolves into a crab named Pico. I think that's true. All right, now, next up, what do we got? So this project I want to dive into. This is, let me throw an overhead view there. This is a Bluetooth grilling thermometer. It's meant for cooking. It's got 6 probes on it. You can get these pretty inexpensively, 20, 30 bucks. You get all these little thermocouple probes. Some of them have their little winder. You can see what a cable mess I have going on here. Some of these have these little winding cable winders there, but I'll pop that off of there. So mess of cables here. You get 6 of these probes. I think they go up to something like 350 Celsius. Pretty hot. You can get even the silicone little end there. And you push that into whatever you're grilling, and it has, you can see a cycling thermometer there that's going through and showing me the 6 temperatures. So if I grab, I color-coded the ends there so I could see who's plugged in where. So if I grab this green probe and hold that, we'll see here 81 degrees on probe 1, the others are in the 70s. I'm not sure why one of them is 79 and the others are 73. Where's probe 3? That's the blue one. Huh. No idea why. So probably those could use some calibration, but I haven't done that. But the thing about this is these are meant to either just show you the display on the screen there, which is great if you're actually hanging out with your grill. But as I mentioned, it's really hot out there right now here and maybe where you are. So sometimes you want to be inside, but keep an eye on temperatures. Of whatever you're grilling. You might also occasionally have to go out and turn things or move things around. But the idea is these can send over Bluetooth to a phone. That's what they're designed to do. However, why stop there when we can also get Wi-Fi involved, I say. So what I've got right here, let's see, can I show? Yeah, I can't show that. Let me hide a screen. Let's do that right there. So what I've got right now is an Adafruit I/O dashboard. You can see here, I'm going to hold that first probe again, which is the one that's labeled green. And if you watch my dashboard there, in a few seconds, I think every 10 seconds or so, I have it sending the temperature up to the cloud and over to Adafruit I/O. You'll see the temperature should go up on probe 1. Oh, now it's making a liar out of me. Let me just make sure this page is actually still connected. Yeah, it is. Okay. I'm not, normally you don't have to just refresh that to see the change. So just to prove that, I'm going to let go of this green probe here. We should see my dashboard there update. There you go. It's dropping. It's now down to 82. I think it's every 5 seconds I have it sending the temperature for all 6 of those probes. There we go, down to 78. So all 6 of those probes send their temperatures via Bluetooth to a feather. This one right here. I've got this feather ESP32S3. And I have a giant battery hooked up to it right now just so that it was easy to deal with and not keep it plugged into the computer. But this feather, thanks to some recent changes to CircuitPython in, I think, 9.1 point something or other, we'll take a look at that in a second, can now use both the Wi-Fi and the Bluetooth at the same time. So what's happening is the temperature from the thermometer is being sent over Bluetooth to this using the iBBQ protocol within Bluetooth. And then this is using Wi-Fi to connect up to the cloud using mini MQTT to send those values up to Adafruit I/O, or anywhere that you have an MQTT feed should work, but I'm using Adafruit I/O. It's easy, and it also gives me the ability to set up that little dashboard that you see there. So both Bluetooth and Wi-Fi on the ESP32S3. This is the no PS RAM 8 megabyte version. Incredible, really cool. We can do all that on the one device, and that means now we can do things like send alerts, share this among other people who are really, really interested in when your barbecued delectables are going to be ready. All right here on a publishable, could be public-facing dashboard. So if you take a look at the feeds that I have, you'll see I have a series of feeds. Here's barbecue feed 1. There may be a way, I'm going to talk to Brent, there may be a way to have this all come over one packet and then peel it apart, or one feed and peel it apart, but it seemed to work really easily to just send this as 6 separate feeds, and then I can do all the dashboard stuff I want with that. So if you look here, let's see, I don't know how much history I'm saving. Okay, you're gonna miss it. I grilled some hot dogs earlier, and I'll show you I did a QuickTime movie of my dashboard as I was doing that, so I'll show you what that looks like as I'm grilling. But kind of neat to run that through, have all those feeds going up, and then do some stuff with it on the dashboard side. So, in fact, let's do that right now. I'm gonna pop open this view right here, and I'm just going to add a QuickTime movie. 1 second. Screen capture. Okay, so this is a screen cap just of my web browser. You can see there, one funny thing is I didn't have probes plugged into 5 or 4 of those slots at first, and those send whatever their maximum is, which translates to nearly 12,000 degrees Fahrenheit. That is not true. But if I scroll forward here, you'll see my first probe is heating up because I just set it in the grill as the grill was heating up. The other is actually just in the sun, so 111 degrees was just that probe sitting there baking in the sun. And then you can see here, I'm going to hit play on this. In a moment here, I actually placed the probes into a couple of hot dogs. So that one drops down to 44 degrees, which is, I set that one out on the counter for a few minutes, but it was roughly 40-something degrees inside the refrigerator. And then set these on the grill. And I'm going to write up a guide. I'll show pictures of what this looks like, but you can just imagine a couple of hot dogs skewered with those temperature probes. And then as I set those on the grill, you'll see their temperature starts to climb. What I did on these little widgets is set them to show me a band of 120 to 165, and that's generally speaking. Oh, you're not seeing this. I'm so sorry. Thank you for saying something. All right, let me redo that. Okay, so here you go. Yeah, I added this and then forgot to actually push the change to the outgoing broadcast. There we go. Still had the old chart. Okay, here's the new chart. So you can see here, initially I had none of the unused probes plugged in, so I'm getting that 11,826.7 degrees. There you can see the first probe got put into a hot dog, so that dropped the temperature down to 44.6 degrees. Second probe, same thing, 42.8. It's pretty consistent. Those were both in the refrigerator. They came out, they sat for a bit, and that's their resting temperature there. And then I'll put these on the grill, and you'll see they'll start to climb. I also plugged in the other probes. So all of them went to ambient temperature, so they're just sitting out, dangling off the edge of the grill there at about 80-something degrees. And then you'll see as the grill heats up those first two hot dogs with their probes on there, I set a band of 120 to 165 as the below it's not warm enough. Most meats in particular, if you're grilling, are going to need to be about 120 if it's beef, 160, 165 if it's chicken. So I just set this range here, 120 to 165, as the good range. So you can see my gauges there have turned green. Now I got these hot dogs good and hot. They're going to go up into like the 170, 180 range there. So that's fine. I think you can eat these hot dogs raw, to be honest, so it doesn't really matter, but you don't want to eat cold hot dogs. So those probes got up to the 190, 200 and some mark, and then I turned them a couple times during that, and probably if you cared, you could watch the time. You can see I have a little chart at the bottom. The chart auto ranged itself for the 11,000 degrees, so it's kind of useless visually on the y-axis. But on the x-axis there, it shows me the time. So I can see I did this at like 147, took it off at 153. Looks like, so you can keep some timing info available there for yourself as well. And took these off and pulled the probes, and I think this is just the probes cooling off on their own. I already pulled them from the hot dogs. So pretty cool, and all of these, if you take a look, I'm going to switch back to the real dashboard view. Let's see, is that the real dashboard view? There we go. So I'll go dashboard, grill dashboard. Okay, you can see that. So here, if I go into edit layout, you can add widgets, you can edit your widgets. So if we take a look at this temperature 1 and edit this little widget block, you can see is coming from my BBQ1 feed. There's the 6 possible feeds I should be using for that. And then if we look at the setup on here, you can give it a title. Sorry, let me get rid of the extra copy of me there. You can set a minimum value on the gauge, so 0 is pretty unlikely. I'm not using this for cold stuff, so we could probably set that down to some reasonable ambient, maybe fridge temperature, set it to like 38 or something like that. I'll go ahead and do that just to see. Maximum value, you know, if it's something you're cooking in the grill, you could get hotter than that, probably unlikely, so I said 300 was reasonable. You can adjust the width of the gauge, the label, I typed in Fahrenheit degrees there. Low warning value, so that's where it's in the red, and up at 120 it goes into the green. High value warning, same thing. Once it gets over 165, I have it go into the red, so you could adjust this. Let's say you didn't want to get it into the red until 185. And interestingly, the little transmitter here only shows whole degrees, but it reports them in, I think, 3 decimal places when it sends that message. So you'll get more precision available to you just by doing this, just by sending it up to your dashboard. So I set it to 1 decimal place. I don't think I need it beyond that, to be honest. 0 would be fine as well. You can add icons. I don't think you can do any other color coding. But here I'll hit Save Layout. So you'll see that one now has a low of 38, a little different than the others. So it's going to show up, even though these are all sitting at 75 degrees, this one will show up different on the gauge here. The other block I have down here at the bottom, if I do Edit Layout, this one is a set of, it'll, I think, only allow, yeah, it'll only allow 5 feeds, which is too bad. I may ask Brent to, could we up that? Is there any reason we can't do 6 on this chart, just so I can get all of my thermometers on there? But this is the, what's this one called? Line chart. So this is showing all my temperatures. It shows the live values. You can also set that to time frames if you want, an hour, 2 hours, 4 hours, 8 hours. I've got some labels on the axes for that, minimum. I didn't do a y-axis maximum. Actually, that'd be smart. Let's say 350. That means it won't go and auto range itself for the 11,000 when I forget to plug in a probe. And hit Update Block. So now if we watch that, let me hit Save Layout, and I can zoom in. I'll have to scroll down a bit, but let's see if I can zoom in. Wait, that one looked good. Okay, so I'll grab one of these probes, hold it in my hand, and then you should see we've got minutes and seconds down at the bottom. So this is what, every minute or so on there, and I've grabbed what is showing up as the blue. This is an area where you can't color code these, but I could plug them in that order so that at least there's some correlation between those colors. But I might ask Brent if it would be possible to do a bit more color coding of some of this stuff, and like I said, expand this to allow more streams into that one widget there, into that line graph. So there you can see, if I let go of this, that'll drop down. I'd put one in my water, but I think it might have hot dog juice on it, and I don't remember which one I used, so maybe I won't do that. Andy says, JP has many barbecues. Yeah, I don't know if I would ever need 6 things, maybe. I don't think my grill is big enough to do like 6 big slabs of whatever you're grilling there. And there you can see, yeah, that's dropping down now, and now they're going to be all at the same, should be all at roughly the same level. So pretty cool. Now this is a brand new thing, like I said, to be able to do both the Bluetooth and the Wi-Fi at the same time in CircuitPython. And there, let me go ahead and plug this in, and I'll show you the code that's running on here. Let's hide this view here, and my Finder. Let's go and open up that code.py. And remember to share it with you. There you go. So there you can see it's actually just, since I plugged it in, it ran through the boot stuff. So you can see there it connected to Shopnet. That's the name of the Wi-Fi that I have. So in the settings.toml file, I've given it my Wi-Fi SSID and password, as well as my Adafruit IO information so that it can publish up to my feed. I'm importing the everything I need for MQTT over Wi-Fi, so Wi-Fi, socket pool, SSL, mini MQTT, as well as all this Bluetooth goodness. So there's the Adafruit BLE, BLE advertising, and the BLE IBBQ, which is one of the many, I can't remember if we call these Bluetooth profiles. I think it's a Bluetooth profile. So we have profiles for heart rate monitors, profiles for bicycle speedometers, cadence counters, those kinds of things, scales. There's this one for a lot of the different inexpensive barbecue thermometers that you can get. This one's called IBBQ. And also JSON. I can't remember how I'm using JSON. Let's find out. So first thing I'm doing is grabbing my Adafruit IO username and key info from the settings.toml file, grabbing my Wi-Fi SSID and password so that we're able to connect. So we do a Wi-Fi radio connect. And then I'm setting up these feeds for publishing. So these are the names of the feeds that they'll go to, which is username, feeds, BBQ123. I may have made those, I can't remember if I've made those public yet, but I will, so that you can click on that page and see if anything's cooking here. That one I'm not using at the moment. Once I connect, I set the client subscribe to that barbecue on-off feed. So this was a, excuse me, I'm about to sneeze. This was, I haven't done this yet, but this was a turn a light on the dashboard when this actually is connected, because I can turn off the Bluetooth side of things, and then I think the temperatures might just all skyrocket, so I'd rather know that it's turned off. We have just a function to run when we're disconnected, let us know, a function for the messages, and then all of the connection for Wi-Fi, SSL, MQTT, and whether we do one of those callbacks when we're connected or disconnected or sending a message. Do the client connect and then set up all the Bluetooth stuff. So we create our BLE radio object. We say we don't currently have the IBBQ connection. I'm setting up 6 variables for the temperatures. Initially, just set them to 0. I create a little function to turn Celsius to Fahrenheit because the messages come in Celsius. And then the main loop of the program. So we scan and then look for the BLE and do a BLE connection. And then if we're connected, we just start looking for messages to come in. So if we get a message, it's going to come as IBBQservice.temperatures. I think there's one other message it sends. I can't remember what it is now. But when I just cast those 6 variables there as the 6 temperatures that come from the message, I can then run them through my little conversion, because they're going to come in initially as, you can see here what's printing out, Celsius. So these are all saying they're roughly 23 or 22 degrees. Again, if I hold one of those, you'll see one of those go up. Just wait a moment. There you go. That third from the last is now saying 29. But that doesn't mean much to me because I grew up with Fahrenheit, so I do that conversion, and that's what I actually send up to the feed. So the main MQTT loop right here, MQTT client, publish to the feed, which feed I'm sending it to, and which value I'm sending, and those are those converted Fahrenheit values. So I just do 6 of those and send them, and then I wait 5 seconds and then do it again. So that results in that right there. So I can zoom back out so that we can see these on one page again. There we go. So those are all the temperatures coming from this mass of temperature probes. I need to come up with a better way to keep those neat and tidy. Sent over Bluetooth to that right there. The little feather grabs those values via Bluetooth, and then it just turns around and sends them over my Wi-Fi access point all the way up to my feed on Adafruit I/O. So pretty straightforward, to be honest. It gives you a lot of interesting new capabilities to be able to take devices like this that were never really made to go up to the big wide world of Wi-Fi, just intercept that information that comes via Bluetooth, and then we can send that up to the cloud and use them wherever you want. Some nice said, I noticed you're not using CircuitPython Connection Manager. It wraps up SSL and sockets. Thank you. I should say no one has looked at this code that I just showed you. I've had 0 reviews on it, so there's definitely clearly room for improvement. Thanks, some nice. I'll take a look at that. I think I just was working from a couple of our sample example code for Adafruit I/O, for the Wi-Fi stuff, and for general BLE. I think we did some previous BLE even for iBarbecue in the past. So I grabbed an old guide of mine to start from there. But yes, thank you. That's good to know that we can neaten that up. So that is it. That's going to be the future of grilling right there. Is having all my info right there on a dashboard. Let me know if you have any other thoughts or suggestions. Otherwise, I'll start writing that up. And in general, if you let me go back to our Learn guide here for a second. In general, let me see if I look up iBBQ. CircuitPython BLE libraries on any computer, guide by Dan Halber. Here's my BLE multi-temperature monitoring. I was using just BLE sent to a clue. If you look at these guides, let me look at Dan's here. We'll mention a bunch of the different services that we've got working. So there you can see pulse oximeter, heart rate monitor, iBBQ thermometer. So that's not a company, or maybe it is, and everyone also borrowed their protocol, but we have, or their service. But we've gotten a number of different devices, inexpensive barbecue thermometers on Amazon that use that standard. If you go back to this guide here that I had done. Inkbird, Easy BBQ, NutriChef, Evoland. These are all, oh, Inkbird's gone. These things come and go. NutriChef. So most likely these are going to use that standard. You may want to get them from somewhere like Amazon or a local store that's easy to do a return. If you do BLE, BBQ. Don't get those expensive ones, but if you get an inexpensive, let's see, BBQ Bluetooth, let's try. Here's Inkbird again, ThermoPro. So you can try these. We can't do a definitive guide as to which ones use iBBQ. I don't know if they ever mention it in their product descriptions. You might go to their site, try to find more info on it, but it's impossible, like I said, for us to kind of keep up with these because they change a lot. But iBBQ, we've found a few different, at the time of that guide, we'd found 4 different brands that all used that protocol. People don't want to write new protocols, so if they can just sort of slide in on existing ones, they'll generally tend to do that. Let's see, what else? Fun fact from Andy Callaway, when Fahrenheit invented his scale, it originally went from 0 to 180, half a circle. However, his thermometer is faulty and red freezing point is 32, not 0. That's why Fahrenheit scale goes from 32 to 212, not 0 to 180 as intended. Oops, I didn't know that. Oh, okay. So that's going to do it for today. Thanks everyone for stopping by. I don't know if Scott is, like I said, I just got back from out of town, so I'm not sure if Scott's doing a deep dive tomorrow or if Foamy Guy is doing one tomorrow over the weekend, but I know that we will be back next week with some of these shows. I'll be doing Product Pick on Tuesday. We have Show and Tell on Wednesday. I think I might be hosting that one, but I can't remember. Check my notes. And we may have Ask an Engineer that night. There's a lot going on with moves and things right now. So stay tuned to the blog. Like I say, I apologize for not posting on Tuesday. I really thought I had, but I didn't. But keep an eye and of course always head to our Discord and poke around. There's usually some people there who can let you know what's going on. Like I said, that is our coupon code for today. So if you want to go grab some cool Adafruit stuff for a discount, then head on over, throw some stuff in your cart, and on the way out, look for the coupon code slot, type in propane, which, by the way, I will share a secret. I'm not using propane on my grill. It's actually natural gas because I have a natural gas line coming out of the house, so no propane tanks for me. I'm very happy about this new grill. All right, so that's your coupon code that'll get you 10% off today until about midnight East Coast time. So go forth and get cool stuff. Thanks everyone for stopping by. For Adafruit Industries, I'm John Park. This has been John Park's Workshop. Bye-bye.
Thank you.